Hi everyone, it's Mr. Ince here with you. We're going to go ahead and take a few minutes to work on completing a triangle congruence proof. A couple things that I want to point out over here to the right side is what I refer to as my tool belt for building proofs. These are 6 different pretty common pieces of reasoning that you may find yourself using in the process of creating a triangle congruence proof. Now down below here in this section, what I've done is kind of created my little reminders of different postulates and theorems that I am allowed to use in order to prove 2 triangles congruent, and a couple that I am absolutely not. Let's run down these lists real fast so that you remind yourself of what they include. So the ones that I am allowed to use, one of them is side, side, side. The other is side, angle, side, making sure that that angle is included between the sides. Then there is angle, side, angle, making sure the side is included between the 2 angles. Angle, angle, side, and then finally HL, which is hypotenuse leg, which is a reminder, deals only with right triangles. So do be careful with that one. A couple that you are not allowed to use, so please do not try to use this as any sort of justification, is angle, angle, angle. That's just not going to work. Or side, side, angle. Not going to cut it. All right, let's get to it. First thing you should always be doing is, hey, let's take a look at the givens. What do I have? What do I know? Then we're going to work from there. So it is given to us that side AE is parallel to side DC. When I see, remember, this symbol here refers to parallel. I notice some people often forget that. When I see that we've got parallel lines working, it reminds me of this tool right over here in our tool belt. And that's that when you have parallel lines cut by a transversal, as a reminder in this picture, these are the 2 parallel lines, that once they are cut by a transversal, then alternate interior angles are congruent. Over here to the left, I'm going to go ahead and put in the sides that are parallel, just kind of a visual reminder for me. So here are my parallel sides. And then we also have a given that side AC bisects ED. Important word there being bisect, considering that the definition means to split into 2 equal pieces. All right, let's get moving. I always like to just kind of work within the picture, develop an argument so that I know where I'm trying to go. All right, what do we got? Well, based on the definition of the word bisect, if AC bisects side ED, that would mean that ED was split into 2 equal parts, and those 2 equal parts are side EB and side DB. Also, I'm taking a look towards the middle here, and it looks like we have a vertical pair of angles. A reminder, over here in our tool belt, that's one of those common things that comes up, is that when you have 2 lines that cross, those angles that are on opposite sides of each other are referred to as a vertical pair, and they are always congruent. So you can use that. All right, we're getting close. So that means that this angle here and this angle here are a vertical pair and therefore congruent. Finally, those parallel lines, we got to get back to them. So our parallel lines are on the outside here at AE and side DC. It looks as if this is a transversal that has cut through and made contact with them, which means that this angle here, angle AEB, would be congruent to angle CDB, and once again, that's because they are an alternate interior pair. All right, looks like we're ready, because when I look back at all my little notifications here, we have angle, side, angle, congruent to another triangle, angle, side, angle. So we're headed towards ASA, but we need to make sure that in this paragraph proof, we can carefully and clearly justify ourselves for each of those steps that we've now discussed. All right, let's get it going. First bullet point. I think we could start by stating that based on the definition of bisect, or you could simply go with, whoa, hello, let's undo that. You could say that using the definition of bisect. Now remind yourself what that did for us. It was the definition of bisect that allow us to say that, so using the definition of bisect, comma, that allowed us to state that side EB was congruent to side DB. Next up, we made this claim about those vertical angles, so let's make sure that we describe that. So we could state that angle EBA is congruent to angle DBC, making sure that we use 3 letters in each of those since there are multiple angles that come from point B. And our reasoning was that they're a vertical pair. Okay, so we've taken care of one side, we've taken care of that vertical angles. Finally, we want to make sure that we express as clearly as we can the alternate interior angles piece, which was based on the parallel lines. So why don't we start out by stating that angle AEB is congruent to angle CDB. And here's the long one, so get ready. Because when parallel lines are cut by a transversal, alternate interior angles are congruent. Okay, I think we're finally ready to kind of write our conclusion to this proof. So now this is the point where you want to make sure that you state your claim of what you used. In this case, we used angle side angle. So you're going to want to start by saying by ASA, comma, and then you can just go ahead and finish with that proof statement right here. So we just provided evidence of why by ASA, triangle AEB must be congruent to triangle CDB. Whew! All right, we did it. A reminder, you can always take a look at the video of the tool belt for building proofs, and you can find that by clicking on the link below. All right, nice job.